Welcome. In this video tutorial we will use WebLink to record gaze while people interact with a gaming console. The tutorial will explain the equipment required and demonstrate use of WebLink's external video component. At the end of the tutorial we will take a quick look at some data in DataViewer. In order to use WebLink's external video component to record from a gaming console, we need an HDMI video capture device. For this project I used a relatively inexpensive StarTech device. Magewell devices are a bit more expensive but also work well with WebLink. There are much cheaper HDMI capture devices available, but we have not tested these. We will also need an HDMI splitter so that the video signal from the games console can be sent both to the gaming console screen and the video capture device. The setup and cabling is illustrated in this diagram. In brief, the video capture device is attached to the computer running WebLink. The video output from the gaming console is connected to the input of the HDMI splitter. One output from the splitter goes to the video capture device and the other goes to the monitor or TV screen that the gaming console is usually attached to. Importantly, the computer running WebLink is connected directly to a second input on the monitor or TV attached to the gaming console. This allows WebLink to show the calibration targets. Once calibration is complete, the monitor input can be switched back to the gaming console. So let's build a project in WebLink. We start, as always, by creating a new project and then dragging a camera setup icon to the timeline. The default settings are fine for this project. Next, we drag an external video component to the timeline. In the Properties panel, you can click the external video source list and select the video capture device. The external video component in WebLink will list any video input that is available to the computer, so if you have a webcam attached, you may see that listed too. If the gaming console is connected to the video capture device via the HDMI splitter, you should see its video output appear in the preview panel. If I select the camera setup component, you can see that it is showing the 5-point calibration model, which is the default model for the external video component. Let's make some adjustments to the general experiment configuration settings. Because the project contains an external video component, you can see in the monitor settings that WebLink has automatically selected the Track External Device button and has correctly filled in the screen resolution details from the video capture device. However, as we saw at the start of the video, we also have a direct HDMI connection from the computer running WebLink to the monitor or TV attached to the gaming console. As such, the gaming console screen is also a connected monitor as far as WebLink is concerned. If we select the Track Connected Monitor option, then WebLink will use the monitor for the camera setup and calibration process, which is what we want. We'll see how the Track External Device option works in the video tutorial that covers tracking tablet devices. You should also uncheck the Use Existing Screen Settings option and provide the correct information about the screen that is attached to the gaming device. I'll add its width, height, distance from participant and its distance from the iLink camera. This last property is important if you are recording in remote mode. We are now ready to collect some data, so I'll click the Run button and enter the participant details. Here you can see both screens simultaneously, the screen running WebLink and the screen attached to the gaming console, which also appears as a second monitor to WebLink. During the camera setup stage, I can check the camera position and focus, and then press C to start the calibration process. After checking that the calibration is good or performing a validation, I can then press O to start the recording. At this point, WebLink stops using the gaming console screen for the camera setup and calibration, and the screen switches to showing the input from the video game console itself. In the WebLink preview window of the external video component, the same video signal is shown thanks to the HDMI splitter and video capture device. You can press F2 to finish the recording whenever you want. The gaze data will be saved to an EDF file along with an MP4 video capture. If you import the EDF into a DataViewer viewing session, you will be able to play back the recording in the playback animation view and perform standard analysis tasks such as adding messages to set interest periods. I'll add a message that indicates when the participant started driving. I can then create an interest period that uses the message I added as the start event and the trial result message to define the end event. With the interest period selected, I can play back the data again and perform other tasks such as creating interest areas. I'll pause the playback and then make a static interest area around this instrument panel as it remains in a fixed location. Of course, dynamic interest areas can be made for other features that are not fixed or which are not present throughout the recording. I hope this video tutorial was useful. Please do check out the other videos in this series, and as ever, if you have any questions, don't hesitate to contact our support service via the support forum or email.